Hi everyone, Chad here. Thanks for joining me. Today our goal is to write a method to be able to measure the plates on the Avant. Plate measurements are an excellent way to measure a column's efficiency. I did a whole intro video about plates, so be sure to check that out. I also have a bunch of other videos about understanding how blocks work or reading instructions and just navigating the method editor in general. So I'll link all of those below. So the method we're going to write today will work with just about any column out there, more or less, and I'll explain all that as we go. So for the setup, we're going to be using 150 millimolar sodium chloride on pump A. We're not going to be using pump B, so that's just going to be water, whatever. And then we're going to inject a salt bolus, which will be 1 molar sodium chloride using a loop. So with this method, we're going to be using about 2% of the column volume for the salt bolus. So depending upon the size of your column, you may need a super loop or a couple 5 mil loops, like kind of put together end to end. All right, so to start, we're going to go up here to the left-hand corner and select the new method button. The next thing we're going to do is get rid of this gradient box on the bottom because we're using SEC, don't need gradients. And then this warning is just so you know that if you're planning on using the phase properties, then the text will change as well. So don't worry about that. We're only going to be using text. The first thing to change is the very first instruction where we pick a base, which is we just have to put in a column. And you can use any of the columns listed here. These are all the columns that are in the Cytiva or GE universe. Let's pick a HiLoad 26600. I want to do the Superdex 200. There we go, and then we'll hit change. Okay, and this box that comes up, all it's doing is we have a bunch of default settings in the method settings phase. And those are listed right here, and this box is going to say, hey, I'm changing those settings to this value, and all that's fine, so we'll hit OK. Speaking of selecting a column, if your column is not in this list right here, you can make your own column by going to Tools, and then Column Handling, and then you hit New. And you just fill out this first portion as best you can, and then you need to do the hardware diameter and the bed height as well, and then you hit save, but I'm not going to do that right now. I actually have a whole video about making your own column, so you can check that out. I'll link that again below. But we're just going to be using this HiLoad 26600 Superdex column right here. Then I'm also going to get rid of as many of these variables as possible, because I just want to make this method as clean for you as possible, just so it's easy to work with. And how I'm going to get rid of a variable is any place I see a variable, which is the capital V, capital A, capital R, I'm just going to click that button, and I'm going to hit clear, OK, and then change. I'm going to leave the system's flow rate at 2.6 mils a minute, but I'm getting rid of the pressure control. Before we can move on from the method settings phase, I need to do a couple more things. I am going to do a pump wash, and I'm only going to pump wash A. Insert, and I want the pump wash to be above the flow. I'll put it right here underneath inlet A and B. Okay, that works. And then I want to be able to rinse the entire system out before I actually change the column from bypass. So if there's any air bubbles that are in there, kind of a buffer, I don't want getting on my column. So to do that, I'm just going to change this base, same as main. I'm going to change it to volume, change, and then that will allow me to go down here to this end block. And now you notice that it's in mils right here. So I'm going to change this to 5 mils. So it'll only take a couple minutes to rinse it out. Change. All right. So now I'm washing my system, flushing it out, and I'm setting a flow rate. Okay, great. So that's the method settings phase. Now I'm going to put some more phases in here. And to do that, I'm going to go to View, Phase Library, and I'm just going to use this user defined phase. And these are just empty phases. See, there's nothing in there right now. Okay, so that's all the phases that I need. Close the phase library. Okay, now for column equilibration, right? Let's look at this. I have the flow running. I've cleaned the system out, but the column valve is still in bypass. So here I'm going to put in a change the column position to column position 1. And then this will allow me to putting an n, like a number right here, will allow me to do a column equilibration. So we're going to do 1 CV for that. All right, so now for the salt injection, I'm going to go to injection valve, and here I'm going to do inject, and then I'm going to do manual load, and then I'm going to change this number right here to 2%, which is 0.02, right? Change. And so what's going to happen is that the system is going to read this instruction. It's going to read these zeros first, then injection valve. Okay, it's going to change the injection valve to inject. And then with this number right here, it's going to wait for 2% of the column volume. And then once it's done that, it's going to read this instruction to change the injection valve back to manual load. And so it'll be done with the injection at that point. All right. So now that we've done the salt injection, we can just go to the run phase. And here, all we need to do is put right here at this end block the length of the run we want to do. So I'm going to do 1.5 CV run. All right, and that's the method. Let's do a couple things. First, let's save this method. And so I want to call this one Pure Plates. All right, the next thing I need to do is I need to tell the method where I want the result files saved. So this is a different kind of save we're going to do. And I don't want to save to the default. I want to save it to the folder I have designated for these kind of videos, which is the training folder. And if you're ever wondering where your file just disappeared to, it's probably in the default folder. Okay, so then let's look at the start protocol. So we probably want the variable list on, and maybe let's say the columns, and we could do like method information. So that'll tell us how long the method will take. And then we're gonna do okay. And that's it. You need to make sure this has a 318 mil column. So that would mean you're injecting 6 mils. So you would need 2 of those 5 mil loops connected end to end to be able to work this method. Let's say you had a larger loop though, like let's say you have a 150 mil super loop and you want to do 3 salt injections in a row, like 3 plate counts in a row, so you can get an average. You can be much more confident of the number you're getting. What you can do then is you can turn on scouting. So here's scouting, but we have to go to the start protocol first. And we're gonna click scouting. So now scouting is part of the whole thing. And then we'll do actual scouting runs. And for this, I'm not gonna do, I didn't change the inlet A and B variables. It's all right. So I'm gonna do flow rate, column position, and length of run, pump. So I'm just basically gonna, you know what, I'm gonna do, yeah, I'm gonna do all of them except for the variables that I forgot. They're kind of sneaky. They're sort of hidden in there. They're really short like that, but that's fine. Okay, and so now this is what we're doing, right? That's the entire run, kind of in short. Let's do 3 of these. So insert. Okay, that would be 3 runs right there. And we can go over here to length of equilibration. And we really only need to make sure the column is fully equilibrated for the first run, right? The length of run, 1.5 CVs, is plenty to be able to wash out any salt that's in there, like for the salt bolus. So we can just change this to like, I don't know, 0.05, right? Just to make sure everything's running before we do the salt injection. So, 5. All right, so that will make our runs much shorter. Okay, and then the last thing I want to show you is how, now that we've got our method, let's say you do the plate counting for this and you're like, okay, great. And then you come back, a few months later and you do a plate count on some other type of column. All you have to do is come in here. Of course, you'd also have to change this in scouting, so don't forget that. But we want to change the method for a different column. We just go in here and we pick another column. So I'm going to do this 1660 Cephacryl S300 column now. I'm going to hit change. And there you go. I don't think this column uses 2.5 mil flow rate, which is kind of weird. So we can look at it in the column handling. We can look it up. So what is it? It's a high prep. Let me move that down. High prep 1660 S300. There we go. All right. See, yeah, the max flow rate, the default flow rate is 0.5 mils a minute, and the pre-column pressure is 0.5. So we need to change that. So this really should be 0. Oh, it's already at 0.5, but the flow rate really should be 0.5. So if it doesn't change, you need to double check it. Okay. I hope this helps with your purifications. Good luck. All right, so how do you do a calculation for plates after you've done a run? I'm going to show you in both the streamlined evaluation module and the classic evaluation module. Let's start with the streamlined. I have a file already pre-selected here, which I did a while ago, but still works. All right, and this is what comes up. Your view might be different, but you're gonna have some curves up here, and what you're looking for is the conductivity curve. And you need to have the curve selection box up, and if you can't find it, you just go to view and then curve selection. And what you'll notice is that there's this f of x on the side, and what we have to do is we have to integrate the conductivity peak. So I'm going to turn off the integration for the UV peak and turn on the integration for the conductivity peak. The other thing is I just really don't like this UV curve here. It's really noisy, and the reason it's so noisy is just because the scale is really, really tiny. So I'm just going to click on this. All right, and you'll notice down here, when you integrate, you get a peak table down here, and so the peak I'm interested in is the one that has the retention time of 70 mils. So right here, that's peak C. But there is no column that tells me what the plates per meter is. So what I have to do is go over here to this little gear, click on it, and select plates per meter, which is right here. And we've talked a little bit about asymmetry. So if you want to turn that on, click this asymmetry 10%. That's the one you're looking for. All right, and this is my result. I have 2,704 plates here, and I have an asymmetry of 1.41. I would say this asymmetry isn't very good, and the thing that's important about plates, just remember, is it's really dependent on your setup. Okay, so we're in the classic evaluation module. The first thing we need to do is open our file, and I have mine pre-selected right here. So I'll just open it. Okay, and your view might look different than this, but the first thing is I've got some curves I don't really want to look at. So I'm just going to get rid of those. I'm going to right click and then go to customize. And I'm just going to turn off all the curves I don't want to see. And the reason the view on each of these curves is weird is because I'm remote desktoping. So anyways, I have the conductivity curve here selected, at least I did. Now I do again. And that's what I want to see. So there we go. That's just the curve itself. Now I want to integrate this curve. So I'm going to go over here to integrate and then peak integrate. And what this box on the left here, window on the left here is saying is what curve do I want to integrate? That's conductivity. And what is the resulting peak table going to look like? Which peak table do I want? I want A. And I have integrated this curve once or twice before. And I know that it tries to integrate all these little blips right here. So what I'm going to do is reject some peaks. I'm just going to do the largest curve, the largest peak, and hit OK. And then here is the resulting curve, and it's been integrated. It's at 70 mils. And so you'll notice it's the only peak that was integrated down here, and it actually has the total number of plates per meter already shown. That's the default for this, but it doesn't have the asymmetry. So how I turn that on is right click and I hit customize, and then I can find it down here. So I'm just going to find asymmetry, which is right here. If you don't have the plates, it's this plate height right here, HETP. I'm going to hit OK. And there you can see the asymmetry. There's the plates per meter, and then there's the HETP right there, the plate height. Okay. You'll notice I get the same number of plates more or less, and I think the reason why, let's see, this one's 2,711, and the other version I had 2,704, and I think that's just because the retention time goes out to a few more decimal places. Okay, I hope that helps.